All right, today we're going to be doing Chapter 2.2, which is an introduction to linear equations, as well as 2.3, which is an introduction to slope. There are two things about linear equations that you guys need to know. There are two forms of linear equations. There is what we call slope-intercept form, which is what we call y equals mx plus b. I hope this looks familiar from Algebra 1, where m is equal to the slope of the line and b is equal to the y-intercept of that line. The y-intercept is kind of a fancy way of saying where we should probably start graphing our line. We will be graphing today, but just not right now. The other type of form we have is what we call standard form. Standard form of a linear equation, is ax plus by equals c. And there are a couple of rules that standard form needs to follow, one of which is that a, b, and c are all integers, and meaning they can't be fractions. All right, so you can't have 1/2 a plus 3/4 b equals 7/9. Can't do that. So you will need to get rid of our denominator somehow, and I'll show you guys how to do that. The other thing is, and this tends to vary from book to book for some reason, but in this particular book, and the way I'm going to quiz you is that the a term needs to be positive. A term needs to be positive, so you can't have negative 3x plus 7y equals 13. Can't have that, at least not in this book. And then the last thing, which rarely ever comes up, is that the expression, or rather, sorry, I'll just make it a, b, and c. A, b, and c need to be fully reduced. Okay? And I'll give you an example of that right now. What does it mean to be fully reduced? What it means is that you cannot have, let's say, 3x plus 9y equals 15. It is not in standard form yet, because 3, 9, and 15 all divide into what number, Matthew? 3. So I can reduce this by dividing by 3, and I get x plus 3y equals 5. Now it's in standard form. Does that make sense, everyone? All right, so if you can reduce your standard form, you must reduce your standard form. All right. So where are we going with this? Let's convert from, let's see here. Can I erase all this stuff here? Yeah, get rid of it. Let's take a look at some conversions. The first thing you're going to have to do is convert from standard to slope conversion. And basically all that means is, and this is where your what do you call those things? The solving for a literal variable. That's where this is going to come in handy. Basically all you're doing is you're going to solve for y in every single problem. So let me give you guys an example. Example 1 here is 3x minus 5y equals 9. So remember, we're trying to get this into some kind of slope form, which is y equals mx plus b. So what I'm going to do is I'm going to solve for y. And how I'm going to do that is I'm going to subtract 3x from both sides. I'm just trying to isolate the y term. So I could go 9 minus 3x, but I'd rather go negative 3x plus 9. Those of you who took the makeup pop quiz yesterday, I think you'll see where this is going. The reason why I put this on your pop quiz is because from here I'm going to divide by negative 5. Now, if you took the makeup pop quiz, if you divided the whole thing by negative 5, that's fine. In this case, because there are two terms, I want you to separate your negative 5 out, because you're dividing everything by negative 5, so it should be y equals negative 3 divided by negative 5 should be positive 3 over 5x. Positive 9 divided by negative 5 should be minus 9 over 5. Raise your hands if you were able to beat me to this form. Good. All right, let's do another one here. If I have 4x plus 3y equals 36, I'm going to, again, subtract 4x from both sides. Remember, we're trying to get our y term by itself. So I've got 3y equals negative 4x plus 36. Cameron, how you doing? Good. Divide by 3 on all three counts. You get y equals negative 4 over 3x plus 12. Raise your hands if you were able to beat me to that answer. Okay, let me give you guys a couple of these to do on your own, and then we'll reconvene in a few minutes here. So, here comes number 3, 7x plus 2y equals 18. And then number 4 is going to be 3x minus 8y equals 56. Go ahead and take care of those two on your own. We'll reconvene in a couple minutes. Number 3, I'm going to subtract 7x from both sides. I've got 2y equals negative 7x plus 18. Divide both sides by 2 and everything by 2. We've got negative 7x over 2 plus 9. Raise your hands if you got that for number 3. Negative 7x plus negative 7 over 2x plus 9. Sorry. Good. Good. Same thing with number 4. I'm going to subtract 3x from both sides. So I've got negative 8y equals negative 3x plus 56. Divide everything by negative 8. So I got y equals positive 3 over 8x. And this should be negative, so it should be minus 7. Raise your hands if you got this as your answer. Y equals 3/8 x minus 7. Good. All right. Let's keep moving, because now we're going to go backwards. We need to convert from slope to standard, and then from there, there's going to be a couple more twists on the problems. So, conversion from slope to standard. And what that means is we're just going to get all variables on one side. Get all the x's and y's on one side of the equal sign. So what does that look like? So I'm going to give you a problem. I'm going to give you, say, that's going back to number 1 here. Y equals 3 over 8x plus 5. Okay, remember, the key thing about standard form is that all the x's and y's are on the same side. So if I'm going to move 3/8 x over, I need to subtract 3 over 8x from both sides. So what I have now is I have negative 3 over 8x plus y equals 5. Raise your hands if you do not follow what I just did. I just moved one thing from one side of the equal sign to the other. Okay, now, remember, the problem with this particular standard form is what, Matthew?
Well, there are two problems. There's a negative, and then there's also a fraction.
It's a negative and a fraction, so I got to figure out a way to kill off this denominator and at the same time make it positive. Max, what do you think? Multiply by what? Say again?
5.
You know, I could multiply everything by 3/8, but that would give me, looks like 9 over 16. There's a number that I can choose to kill off that denominator. Matthew?
Negative 8.
Negative 8. If I multiply by negative 8, Max, here, I'll show you what's going to happen. If I multiply negative 8 into here, what's going to happen is negative 8 and 8 are going to cancel. Negative times negative is positive, so I get positive 3x. I'm going to put a negative 8 into here, multiply it by y, so I get minus 8y. And then the right side is going to give me negative 40. And that is the answer that I'm looking for. A is positive. They're all integers. Cannot be reduced. I'm done. After I do this. Forgot. Will ask you to identify A, B, and C. A, in this case, just make the association. A is going to be 3. B is going to be negative 8. And C is going to be negative 40. Raise your hands if I lost you with that step. You're just making the association is all you're doing. Kenny, you doing all right over there?
Yep.
Good? Good. Nate, what's up?
So in the first part, when you're multiplying negative 8, you only do that if you have a negative fraction in the base.
Exactly. If it had been positive 3/8, we would have multiplied everything by positive 8.
And it would just be the opposite of what the denominator is, right?
Yeah. It's the same number as that denominator. So, what's up? Because, remember, so in order to do algebra successfully, we need a do I'm sorry. Time out. What we do to one thing, we need to do to everything to keep it balanced. All right? So it's almost like the distributive property. I'm going to make a quick little example here. If I do 8 times 3x plus 4y equals 7, in order for this equation to stay exactly the same, if I multiply one thing by 8, everything needs to be multiplied by 8 for it to stay the same. Okay? So it's just to keep it balanced, and that's all it really is. Sorry about that. I'll have to edit that little stuttering session out of there. Okay. Number 2. Let's see. How about something easier? Y equals 7x minus 5. Okay. Remember, get all the x's and y's on one side of the equal sign. So I'm going to go ahead and subtract 7x from both sides. Negative 7x plus y equals negative 5. Okay, what's the last part of this problem here? Wally, what do you think? No, actually, that's not quite it. We got to do one last thing, Dom. Get rid of that negative a. So what do I got to multiply this whole thing by? Negative 1. Now, so again, same thing. Since I multiplied this by negative 1, it has to apply to everything. So I got 7x minus y equals positive 5. And now, Wally, I'm here to do a, b, and c. In this case, it would be 7, negative 1, and 5. Let's move on to number 3. Ooh, different one. X equals negative 2 over 7y plus 3/4. The first step should be a piece of cake. What do I need to move to that other side here? Chief. Y. So I'm going to go ahead and add 2 over 7y. So I get x plus 2 over 7y equals positive 3 over 4. Now, we've got to figure out a way to get these fractions out of here. So I have to multiply these terms here by a number that can cancel a 7 and a 4 at the exact same time. Take a second and think about what that number is going to be, and then raise your hand and let us know what you got. Ty. 28 would be the correct choice. 28 here, 28 here. I'm going to distribute that into the x. I got a 28x. If I distribute 28 into 2/7, the 28 and the 7 are going to cancel, leaving me a remainder on 28 of what number? What number is going to be remaining on top? Chris? 4. So I got a 4 here. 4 times 2y is 8y, and that's going to equal 28 divided by 4 is 7, 21. Raise your hands if you beat me to that answer here. Actually, wait a second. We're not done yet. I always forget this part. I don't know why. 28, 8, 21. Now raise your hands if you beat me. Okay, good. Give you guys 2 to do on your own. So why don't I give you, how about y equals 7 over 12x plus 1. And then number 5 here is going to be y equals 3/4 x minus 5 over 6. That one is a tricky one, all right, number 5, so just keep that in mind. Good. All right, number 4, I'm going to go ahead and subtract 7 over 12x. So I've got not a lot of space here, but that's okay. I can work with that. That's good. I like that. You got space. So I'm going to back this up here. So I've got negative 7 over 12x plus y equals 1. Who can raise their hand and tell us, what do I need to multiply the entire thing by? Yemsi. Okay, 12 works. There's one that will do both jobs at the same time. 12, Beth? Negative 12 would be more ideal. So if I multiply everything by negative 12, that's going to go away. I get 7x minus 12y equals negative 12. Raise your hands if you got number 4 correct. And that thing that I always forget to do. It's a equals 7, b equals negative 12, and c equals negative 12. Okay, no secret here. I'm going to subtract 3 over 4x from both sides. So I get negative 3 over 4x plus y equals negative 5 over 6. Kenna, what did you choose as your number to multiply in? You did 24. Raise your hands if you got something just a little bit more efficient. Julia? 12. And actually, in this case, Dom, it's going to be not just 12, negative 12. If you did 24, it's not a big deal. It just means you have to reduce at the end, right? Because in order to get everything in standard form, it needs to be fully reduced. So that's going to get out of there. I have a 3 left over. That's 9x minus 12y equals 2. That would be 10. Yes? So A equals 9, B equals negative 12, capital B, and C equals 10. And you are done with that problem here. Raise your hands if you're 2 for 2. 2 for 2? Okay, good. All right, let's delete some of this stuff. Okay. Oops, crud. All right. So once something's in standard form, why do we care? Why do we care that we want something in standard form here? So the uses of standard form come from the ability to identify, so we can identify X and Y intercepts. An X-intercept and a Y-intercept is where that point or where that line crosses that particular axis. Chris, how you doing? So, for example, this point right here is an X-intercept. This point here is a Y-intercept. Right, so just so you guys know your differences between X and Y intercepts. Hopefully you guys remember that from Algebra 1 too. Okay, so when we're in standard form here, if I gave you, say, 2x minus y equals 5, and I asked you to find X and Y intercepts, here's what you do. You set each one individually equal to 0. So let me show you what that means. If I wanted to find the X-intercept of this particular line here, I would set y equal to 0 and then solve for x. So 2x equals 5, x equals 5 over 2. Go ahead and leave that as your answer for now. We will come back to that in a second. I just solved for the x-intercept. I want the y-intercept, which means I'm going to substitute 0 in for x, which means I'm going to get 2 times 0 minus y equals 5. That thing is out of there. Negative y equals 5. Negative y equals 5. I'm going to multiply by negative 1. Y equals negative 5. Now what this means is that your x-intercept is at 5 over 2 comma 0, and your y-intercept is at 0 comma negative 5. And that's all it's telling you when you do this, finding x, y intercepts. And it makes sense, right? If we look back up to this drawing here, if we look at an x-intercept, its elevation is at nothing, right? We haven't gone up anywhere, which makes sense why its y-coordinate is 0. If we look at the y-intercept, it hasn't traveled left or right, which means that its x-coordinate is going to be 0. Let's do another one. Get rid of that. Okay, if I asked you to find the x-y intercepts for, let's see here, how about something a little harder? Number 2 here, 3x equals 4y minus 5. Well, the problem with this thing is that it's not in standard form yet. So let's go and just put it in standard form. To put it in standard form, I'm going to have to do what, Soph? Okay, so how do I do that? Subtract 4y from both sides. So 3x minus 4y equals negative 5. And now here I'm going to have my x-intercept, which is 3x minus 4 times 0 equals negative 5. That's out of there, so 3x equals negative 5. X equals negative 5/3. On the right, I'm going to go ahead and find my y-intercept, so that's 3 times 0 minus 4y equals negative 5. That's gone. Cutting through all the red tape, y equals 5/4. So my x and y intercepts are going to be, looks like negative 5/3 comma 0, and then 0 comma 5/4. Questions on this? Pretty easy? Miss Connolly, pretty easy? Sweet. Let me give you guys a couple of these to do on your own. Number 3 here is on your own. 3x minus 6 equals y. You're going to have to manipulate this a little bit. 5x plus 2y equals 6. Go ahead and take care of those two on your own. Just find the x and y intercepts. Jeez. I hate when that happens. That always seems to happen when I put it on pause. Okay. Let's see here. We know that this one is really going to be 3x minus y equals 6, right? We know that, yes? Okay. So, what is the x-intercept of this function here? Chief, what'd you get? Give me the x-intercept, please. Okay, that's all right. Brianna. Dom. Positive 2, right? 2 comma 0. And then y-intercept, Chris. Negative 6. 0 comma negative 6. Nate, what's up? Yeah, no problem. Let me just go ahead and erase this thing real quick. Okay, the y-intercept was achieved by setting, remember, it's achieved by setting the x equal to 0. So it'd be 3 times 0, minus y equals 6, yeah? 3 times 0 is 0. All I have is negative y equals 6, so I'm going to multiply by negative 1. So y equals negative 6. In the original problem, it was to the right of the equal sign, so we rearranged it into 3x minus y equals 6. Max? Because y wasn't by itself yet. It was negative y equals 6. And so remember, it's just like in the middle of an equation, you solve when you're solving for x or for any variable, you have to get it completely by itself. So no numbers in front, no negative signs in front, no nothing. All right, let's see. Let's go ahead and erase some of this garbage here. Okay, x-intercept. What did you get for the x-intercept of this problem here? Caden, did you get something? 6/5, yeah, 6/5, comma 0. Caden, you want to keep going with the y-intercept? Okay, in this case, it's not 3, 0, because it's the y-intercept, so it'd actually be 0, 3 is what you want. Remember, because this is your 3 is the y-coordinate. Okay, good. Raise your hands, you got both correct. Both correct. Good. All right. Time to graph. Don't even give me that. Graphing's easy. No, it's not actually. It's quite simple. Okay. So, 2 methods of graphing. Stick with me, people. Okay. There is slope-intercept form, which is y equals, say, negative 2/3 x plus 4. What that means is my y-intercept is at 0, 4, so 0, comma 4 is where I start. And then we didn't cover this quite yet. That'll be in the next section in a few minutes. Negative 2/3 is my slope, and that tells me to move which way. If anyone remembers anything from Algebra 1, Nate.
Down 2/3.
Down to, and I'll say right. How about that? right 3. Okay, so what that means is I'm going to go and graph this thing. I start at 0, 4, so 1, 2, 3, 4. I start here. I'm going to go and draw the rest of my hash marks. On your quiz, you will be given graphs, like those little square graphs inside your quiz, but for now, you're going to need to kind of do it the way I'm doing with the little tick marks. We start up 4, we move down 1, 2 to the right, 1, 2, 3. How many points do we need to graph a line? 2. Connect them. You're done. Questions on graphing? Okay. Let me give you guys 2 to do on your own. Y equals 1/5 x minus 3. And then y equals negative 2x plus 5. Go and take care of those 2 on your own. Just go ahead and graph them, please. Okay, let's do this real quick because we got to do standard graphing and then we got to move on to slope. So, yeah, you guys are getting a double header today. Okay, down 3, up 1 to the right 5. 1, 2, 3, 4, 5. Yes? Cool. Up 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Up 5. Down 1, 2. To the right, how many? To the right, 1. Remember, all numbers are, on some level, fractions. Okay, questions? Raise your hands if you got both of these graphs marginally correct. Good. Pretty simple. All right, graphing from standard form. You have 2 options that you can have on the quiz. 1, you can either convert to y equals mx plus b, which is what we learned. You can solve for y and then graph it. Or you can use the intercepts to graph your equation. So if I have, say, 2x plus 5y equals 10, 10, I can either convert this into slope-intercept form, in which case you just need to trust me. It is y equals negative 2 over 5x plus 2. You can graph it that way. So why don't we just go ahead and graph this one like this. Up 2, after I draw my little tick marks here. So up 2. Down 2 to the right 5, right? 1, 2, 3, 4, 5. What do I have? Just enough space. Yeah? Or I could have identified, let me get some ketchup here. I could have identified my X and Y intercepts. So my X-Intercept, what's my X-Intercept going to be? Yeah, let me see. 5, 0. My Y-Intercept is going to be what, Chris? 0, 2. Well, what do you know? 0, 2 is here, 5, 0 is here, and if I connect the lines, do you see kind of a blend of ketchup and mustard right there? It's the same line, right? So 2 methods of doing it. You can either use intercepts or you can convert to slope-intercept form. Whichever you decide to do is going to be perfectly okay on the quiz coming up. So, number 2, let's try another one. X plus 2y equals 7. McKenna, what do you want to do? Do you want to convert or do you want to intercept? Convert. Let's go ahead and do that. If I convert, I'm solving for y. I'm going to go ahead and subtract x from both sides. 2y equals negative x plus 7. I'm now going to divide everything by 2. Y equals negative x over 2 is the same thing as negative 1/2 x plus 7 over 2. Let's go ahead and graph this thing. Seven over 2 is what, 3.5? So I'm going to move up 1, 2, 3.5. I'm going to move down 1 to the right 2, so down 1 to the right 1, 2. And just for fun, I'll do it again. Down 1 to the right 1, 2. and your graph should look kind of like that. I'm getting better at using this thing. Good? Okay, I'll give you guys one to do on your own. Number 3. X over 3 plus y over 2 equals 15 over 2. First of all, what do you need to multiply this thing by to get it into standard form if you decided to go that route? What would you need to multiply this whole thing by? Emily, what do you think? 6. There's your hint. So, we know that we need to multiply everything by 6, right? We established that before I paused. So here, I'm going to go ahead and multiply everything by 6. 6 divided by 3 leaves me a remainder of 2. Now, whatever is remaining still gets multiplied. Keep your eye on the prize. The whole time we were multiplying, right? So 2 gets multiplied into x to give me 2x. 6 divides into 2 to give me 3, but remember, we were multiplying the whole time. So it's 3 times y, which is 3y. 6 divides into 2 gives me 3. Remember, we were multiplying the whole time, so it multiplies back in to get me 45. Now from here, some people decided to switch forms. That's not a big deal. I'm going to go and subtract 2x from both sides. 3y equals negative 2x plus 45, and now I'm going to divide by 3 everywhere. So my final equation is y equals negative 2 over 3x plus 15. Raise your hands if you got that far on the problem. Excellent. That's the hardest part of the problem right there. The second hardest part is to make sure you draw a graph that scales up to 15. Okay, I'm way up here. From here, my slope tells me to move down 2 and to the right 3. So down 2 to the right 3. I'm going to do it again. Down 2 to the right 3. And that's about, I would consider that full credit. Okay? Raise your hands if you got that. Nice job, Julia. Gabby, what's up?
Is it okay if we did it the other way too? Like,
With intercepts?
Yeah.
Which means you had a y-intercept of 15, I'm sorry, an x-intercept of 15. Sorry, just kidding. A y-intercept of 15?
yeah, and X-intercept is 47 over 2.
47 over 2, which is 22 and a half. No problem.
Okay.
That's perfectly fine. Whatever you guys decide to do. Okay, cool. Let me pause real quick. Guys, take a couple minute break while I get the next video ready.